Find the derivative of y equals cosine 2t, A, by using the chain rule, B, by expanding the expression and differentiating the result. For part A, y is made up of a trig function cosine of an entire expression, 2t. Since what's inside the trig function isn't just a t, but rather an entire expression, we have to use the chain rule for the derivative. The derivative, y prime, or dy dt, will be found by taking the derivative of the outer function, which is the cosine. The derivative of cosine is negative sine. We leave the inside alone, exactly as we see it, but then we need to multiply by the derivative of the inside, since the inside is not just a t, but rather an entire expression. The derivative of the inside, 2t, will be a 2, and that multiplies the entire result. That's the chain rule. That 2 is not inside the sign, so you do not want to multiply these two together. The 2 is multiplying the entire sign, and it can move to the front of it with the negative, and we get a derivative of negative 2 sine 2t. For part B, we're going to expand the expression y equals to cosine 2t. Cosine of 2t has an identity, the double angle formula for cosine, and it's equal to cosine squared t minus sine squared t, or it's equal to 2 cosine squared t minus 1, or it's equal to 1 minus 2 sine squared t. Any of those can be used. I'm going to use the last one, just the one with fewer trig functions in it. The second one and the third one, those are the ones that have the fewest trig functions. I'll just use the third one, the last one here that I'd written. But any of the three will work. Let's take the derivative of that. But I'm going to write it one more time and say 1 minus 2 sine t times sine t. And that way I can actually make use of the product rule for the derivative. The derivative, y prime, which can also be called dy dt, will be the derivative of the first term. The derivative of 1 is a 0. And then we have the second term. The derivative of that will be a product rule. We have a negative 2 that will come along. The derivative of the first expression, sine of t, will be cosine of t times the second expression left alone. We again have the negative 2. It comes along with the result. We'll leave the first expression alone, sine t, and multiply by the derivative of the second expression, which is cosine t. Now if you look, we have two matching terms, a negative 2 cosine t sine t and a negative 2 sine t cosine t. The order of multiplication doesn't matter, so those terms match. And this is equal to negative 4 sine t cosine t. Well, there is an identity. If we separate the 4 into a negative 2 and a positive 2, I'm specifically keeping the positive 2 with the sine t cosine t because that's the double angle formula for sine of 2t. In reverse, sine of 2t equals 2 sine t cosine t. Therefore, 2 sine t cosine t can be replaced with sine of 2t. It's the double angle formula in reverse. And if we replace it, we have negative 2 sine 2t. And if you look, that's the exact result we had for the derivative in part A.